Okay, good afternoon, everybody. So it is Mike Lai, the Editor-in-Chief of the Journal of Shipping and Trade. Thank you for attending this webinar, which is a part of the Knowledge Transfer Forum organized by the Faculty of Business of PolyU in collaboration with our Shipping Research Center. The topic of today's webinar is about port resiliency and sustainability. So as you know, in recent years, there are lots of issues about port management with a lot of unexpected events causing disruptions in port operations. For example, the COVID-19, which has been lasting for 3 years, has been causing congested port in different areas of the world. For example, in North America, so there are disruption due to the COVID-19 control, leading to the shortage of port workers and truck drivers in handling the cargo movement. We also see that the grounding of vessels in Suez canals has caused suspended operations of the canals, disrupting the shipping schedule and port operations in the downstream. The climate changes can also lead to suspended port operations due to extreme weather, such as typhoon or heavy rainfall. Nowadays, managers for port operations need to better prepare for the risks arising from the different unanticipated events to ensure sustainability in port operations. Now, in this webinar, we have invited 3 speakers to share their research about port resilience and sustainability. This sharing will be moderated by Dr. Yang Dong. After the sharing, we will have time for Q&A sections. Now I invite Dr. Yang Dong to introduce our speaker. Dr. Yang, please.
Okay, thank you, Mike, and thank you all. Okay, thank you for your participation. Today, we are very lucky to have 3 outstanding young scholars to present their research to us. And all of them have very good publication records and very good at shipping and transportation research. So the first one I would like to introduce Dr. Wang Kun from School of International Trade and Economics at the University of International Business and Economics. And Dr. Wang actually graduated from our department at PolyU, and I think he's one of the top students in our department. And he obtained his PhD from UBC, University of British Columbia. And then he came back to Beijing and worked at Beijing since until now. And now I will give the time to Dr. Wang to start his presentation. Dr. Wang, please.
Thank you, Professor Yang, for the introduction, and also thanks for the invitation to this webinar, SRC webinar, and also thanks Professor Mike Lai for the introduction. Okay, can I share my screen? Let me try.
Yeah.
Okay. Okay. So can you see my screen?
Yes.
Okay. Okay, thank you, everyone. Good morning, good afternoon, and good evening, depends where you are. Thank you very much for attending this webinar. So today I'm gonna talk about one topic, is about the container ship market turbulence, which is the actually the volatility of the shipping market. So my focus is on the drivers of the volatility of the shipping market, because we know especially after the pandemic happened, the shipping market, global shipping market, has a lot of the turbulence, just like Professor Mike Lai said, the port congestions and also the surge of the freight rate, especially the container freight rate. So we have seen a lot of the volatility in the shipping market. So our question is, what are the drivers? Okay, so we know the drivers of the volatility can be from the demand side, which is the international trade, and also can be from the cost side. We know the crude oil price is also very volatile. So in this study, we are trying to empirically and theoretically detect what are the drivers from the demand side and the supply side. And one more important question is about the impact of the shipping alliance. So we know the shipping market structure is highly affected by the shipping alliance. So the question is whether the shipping alliance will increase or decrease the volatility of the shipping market in terms of the freight rate. So this is our research question. So this is the joint paper by myself, Kun Wang, and also some other co-authors, also Professor Zheng, who is also giving the talk next. So before my talk, let's look at some figures. So this is the container freight rate of the Chinese routes, the Chinese container freight index. It's different years from 2006 to 2019, and you can see the freight rate, container freight rate is very volatile, okay? So at the bottom, as you can see in 2016, the bottom, and you can see the top of the 2018. So you can see the difference can be very huge. So this shows the freight rate is very volatile, okay? So this is before the pandemic. And after the pandemic, you will also see a very dramatic increase in the container freight rate in 2021. And I think the trend also goes on in the 2022. But recently, I see the freight rate dropped a little bit. But you can see actually the pandemic has also resulted in a very volatile freight rate. So what is the consequence? One immediate consequence is the volatility of the shipping liners' profit margin. So this diagram shows the profit margin of the average shipping liners, okay? So you can see that in the past decades, the shipping liners' profit is very uncertain. Sometimes they incur some positive profits, but sometimes they can lose a lot of money. And one interesting thing is after the pandemic, since the 2020, we see the freight rate goes up quite dramatically, and this also drives up the shipping liners' profitability. The profit margin can be as much as more than 50%. So a lot of the shipping lines actually earned a lot of money in the past 2 years. So I think no one likes the volatility, right? So the freight rates and the profit volatility increase the risk for the shipping lines and also for the whole shipping industry, including the ports and the logistics providers. And if we look at the global supply chain, the volatility of the freight rates also increase the uncertainty on the manufacturers, on the retailers, and also on the customers. So actually understanding the drivers of the volatility is very important in the production planning, in the transportation planning, but actually this topic is not very well studied, especially for the container ship market. So when you try to think about the drivers of the volatility of the freight rate, let's look at the freight rate. Intuitively, the volatility of the freight rate can come from two sides. One is the demand, one is the cost. The demand is the international trade volume volatility. The goes up, goes down. And the cost, we know that the crude oil price is also very volatile. So if you look at this figure, so this shows the crude oil's price, also very volatile, okay? Together with the international trade from the demand side and the fuel price from the cost side. So I think that these two factors will contribute to the volatility, okay? But one more important, if you look at the shipping market, the container shipping market in details, you will also notice the market structure is very special. So since the 1990s, the market has been been dominated by the global, by the shipping alliance. The first shipping alliance is the Global Alliance established in the 1990s, okay? So the shipping alliance actually is a kind of capacity sharing among different shipping liners. So in the past, they have the shipping liner conferences, but in the 1990s, the shipping liner conferences has quitted the history, okay? So it is replaced by the shipping alliance. So what is the shipping alliance? It's actually a capacity sharing mechanism. So within one market, the different ship liners, they will pool their capacity together. So they will joint operate. So if you are a shipper, okay, when you book a slot of the on one route, actually sometimes you are booking from the joint alliance, not from an independent shipping line. So basically, this is a capacity sharing mechanism. But the capacity sharing is allowed under the shipping alliance, but the price coordination is actually forbidden by the antitrust law. So the different governments allow the shipping alliance to share the capacity, but not coordinate in price. Okay, so this is a very important feature in the container shipping market. So here I give you a table showing the major shipping alliance in the market. Okay, over years, the 2014. The Maersk and the MSC, they form 2M, and also other shipping lines, they form O3, G6, CKYHE. So these shipping alliances actually occupied the majority, or I can say almost the whole market. You can see the total market share is over 70% controlled by the shipping alliance. And some major structural change in 2017, O3, G6, CKYHE, they restructured among the members. So they formed the Ocean and the THE alliance, okay? And also with some merger acquisitions among shipping lines. So in 2020, so we have seen basically the current structure of the shipping alliance, okay? So one research question, very important, not only the academic question, but also the practical question is, what is the impact of the shipping alliance on the freight rate volatility? Okay, even more specific. So what is the impact of the shipping alliance can affect the or mediate the role of the demand volatility or cost volatility on the freight rate volatility? Okay, so we know the demand volatility from the international trade or the cost volatility from the oil price volatility, they contribute freight rate volatility, but what is the mediating role of the shipping alliance? Whether the shipping alliance increase or decrease the contribution of the demand side or supply side volatility? Okay, so this is our research question. So with this research question in mind, actually, we also notice a very important industry background. So we know in June 2022, just last month, the Biden has actually warned the shipping alliance because he thought that the volatility of the freight rates can be blamed by the shipping alliance, because he said that, okay, so the shipping alliance should be blamed to cause the retail price hikes in the United States. We know the US is facing very serious inflation rates in the recent months, right? So Biden just signed the Ocean Shipping Reform Act, just signed on this new bill. Actually, in this new bill, the US government will be more active to intervene the shipping market, especially to investigate the possible monopoly power of the shipping alliance. So understand this question is very important, not only academic, but also for the shipping industry and also the global supply chain. Okay, so this is our research question. So what are the drivers of the volatility of the freight rate or port charge from the demand side, international trade volatility, or from the cost side? Okay, I know what is the mediating role of the shipping alliance played in this part? So we deal with this problem with both economic model and an empirical approach. So in the economic model, actually, because of the time limit, I will not go into the very details, but some basic element I try to explain. So we introduced the stochastic demand of the shipping market represented by this parameter capital A, okay? And also in the shipping liners or the shipping alliance profit function, we introduce a stochastic operating cost, C, okay? So this is the shipping lines or shipping alliance operating cost, so which is also a random variable. So it has some volatility, right? And also this market demand, capital A, is also stochastic, has some volatility, okay? And then we assume that if the shipping lines, they join in the alliance, their operating cost will be lower, so represented by this delta. So this delta times C, if this delta is smaller, which means the shipping alliance will bring more economies of scale, economies of scope to reduce the operating cost of the shipping lines. Because we know the shipping lines, they join in the alliance, one major motivation is the cost reduction, right? Because they can share some resources, so achieve the economies of scale. So we solve the model of the market equilibrium, and we actually focus on the variance of the equilibrium market freight rate and the port charge. So this small f represents the freight rate in the market. This capital T represents the port charge. So this subscript I stands for the case without shipping alliance. Okay, so this subscript capital L represents the shipping alliance case. So we solve the model by assuming the shipping alliance or the ship liners, they do Bertrand competition or Cournot competition, depending on what is the decision variable, okay? But the conclusions are very clear. So if the demand is stochastic, okay, so then the shipping alliance will lead to higher volatility of the shipping freight rates. So what does this mean? This means, okay, if the international trade market is volatile, the shipping alliance will increase the volatility, okay, of the freight rate. But on the other hand, on the contrary, if the volatility is from the fuel price, is from the cost side, the shipping alliance is actually help to reduce the freight rate volatility. Okay, so which means the shipping alliance plays different roles to mediate the volatility from the demand side and the supply side, opposite. So what is the intuition behind this proposition? It means that if the market demand is volatile, increase or decrease, okay, because the shipping alliance is basically a monopoly power, it can utilize this demand change, okay, to benefit its profit, joint profit. So it will actually magnify the demand volatility reflected in the shipping freight rates, okay? But on the other hand, because the shipping alliance as a corporation, they can internalize the cost, operating cost, compared with independent shipping lines. The shipping alliance, they can actually internalize the cost. So it will actually reduce the volatility from the fuel price. Okay, so this is basically economic intuition behind this very important proposition, okay? So we get this conclusion. Okay, so we know the demand volatility contributes to freight rate volatility. Cost volatility also contributes to freight rate volatility. What is the role of the shipping alliance? It reinforces this cost side this demand side volatility, but weakens this impact of the cost volatility. Okay. So because of the time limit, I will skip the other propositions, but I think this proposition is the fundamental finding of this paper. Okay, so with this theoretical prediction in mind, we actually try to come up with some empirical evidence. So actually we collect some panel data from the shipping market. We collected 10 routes, freight rate, and also bilateral trade fuel price data for 10 routes from China to rest of the world, as listed here. And also the time period from the 2010 to 2021. So it covers the pre-pandemic and after the pandemic period. And how do we quantify the volatility, right? Because we are concerned about the freight rate volatility, the demand side volatility reflected by the bilateral trade, okay, and also the cost of volatility reflected by the fuel price. So we adopt a time series model called GARCH. So this GARCH model, I'm not able to go into details. If you are interested, you can read some papers, especially some financial studies. They commonly use the GARCH to detect the volatility of a particular variable, okay? So we borrow this GARCH model to calculate the volatility of the freight rate, volatility of the trade, bilateral trade, and the volatility of the fuel price, okay, for 10 routes between China and other countries, other major markets for different time periods. So this consists of the panel data. So here I just show you the GARCH volatility results for selected, say, China-Europe route. So this is the volatility of freight rate. This is volatility of the trade, and this is the fuel price. Okay, so the other issue is, okay, so we know how to calculate the volatility, but how do you measure the power of the alliance? Actually, the shipping market is very complicated. It's a very complicated market. If you look at the shipping market on the route basis, it not only have the alliance, it also has independent shipping lines, right? So let me just give you an example, okay? So if you look at this hypothetical example, this is one route. We assume one alliance called 2M. It accounts for 70% of the route market share, and also an independent shipping line, Yangming, accounts for 30%. Okay, so if you look at another case, another hypothetical case, there are two shipping alliances, okay, 2M and Ocean. They totally account for 70% as well, and also another independent Yangming 30%. So how do you distinguish this case and this case? Okay, how do you distinguish this case and this case? Which one has larger market power by the shipping alliance? Okay. Okay, if make it more complicated, okay, we compare this case and this third case. We have 2M and Ocean as well, but each only account for 35%. The total is also 70% as the second case and the first case. So how do you measure the dominance of the alliance on each market? Okay, this is not a straightforward research question. So how do we deal with this empirical problem? Actually, we come up with a variable, which is the interaction between the total market share of the shipping alliance, okay, and the HHI index of the shipping alliance. So this HHI index of the shipping alliance actually measures the concentration or the competition degree among alliances themselves. Okay, so if you look at this case, the first case and second case, the HHI of the shipping alliance in the first case is 100 because there is only one shipping alliance dominate. Okay, but for the second one, the shipping alliance, the HHI is, you can calculate, okay, so 0.6 times 0.6 square plus 0.1 square, okay, 0.46, okay? So for this one is 0.35 square plus 0.35 square. So if this HHI of the shipping alliance is larger, it means the shipping alliance is more dominant, conditional on we have the same market share of the shipping alliance on the route. So if you want to measure the dominance of shipping alliance, you'd better consider these two factors together. So we come up with this interaction term. Okay. Okay, so then we just show some evolution of the shipping alliance market share on different routes. I just divide the shipping routes into eastbound from China to the east part of the world, and westbound from China to the, eastbound is from China going to the east. It's actually going to North America and South America. And westbound means China goes to Europe, goes to Africa. Okay, so I just highlight 2 time points, 2014 and 2017, simply because there is some structural change of the shipping alliance in these 2 years. I will come back to this issue later on. Okay, so we come up with this empirical regression. Okay, empirical regression. So the dependent variable is the log of the freight rate volatility. Okay, and the independent variable is the log of the, this is the trade volume volatility, which measures the volatility from the demand side. And this is the fuel price volatility, measures volatility from the cost side. Okay, so we expect alpha 1 and alpha 2 should be significantly positive. Okay, which means the volatility from demand and cost will contribute to volatility freight rate. And more interestingly, we include the interaction between the demand volatility with the shipping alliance dominance variable we come up with earlier. Okay, so we have this green color interaction studying the mediation impact of the shipping alliance on the contribution of the demand volatility to the freight rate volatility. And also this purple interaction term measuring the mediation effect of the shipping alliance on the impact of the cost side volatility on the freight rate volatility. Okay, am I clear? And we also control the fixed effect, route fixed effect, time fixed effect. And we all know that there may be some policy change and trade agreements signed and occurred on particular routes over some time. So we also control the two-way month and route, year and route fixed effects. So all the other policy impacts and confounding factors are actually removed from this regression. So this makes our empirical results should be convincing, right? So let's look at the regression results, okay? So I've tried quite a lot of the specifications and the robustness tests. I can tell you the results are very robust. So firstly, as you can see, the trade is demand side volatility is actually positive, significant positive. But for this model 1, okay, for this model 1, we do not consider the interaction between the demand side and the cost side volatility. Okay, we just include the demand side and the cost side volatility independently. But you can see this sign is significant negative. But if you look at the interaction, so this interaction, this term is positive. Okay, so the combination of this term and this interaction term is actually positive. Okay, so if you look at this interaction term, it means the alliance, more dominance of the alliance will increase the impact of the demand side volatility on the freight rate volatility. Okay, so this actually supports our theoretical prediction. The shipping alliance increased the volatility from the demand side. But for this interaction term, the shipping alliance interact with the fuel price volatility is negative. Is negative, which means the shipping alliance helps to reduce the freight rate volatility from the supply side. So if we also consider the interaction between the demand and the cost side volatility, we include this interaction term, the effects becomes more obvious. Okay, so we have also tried other specifications like dynamic panel regressions and other regressions, the results are the same. Okay, but some of you, if you are good at the econometrics, immediate question you may ask is the endogeneity problem, right? Because the you may argue that, okay, the freight rate volatility can be mutually causal with the shipping alliance, right? For example, if some routes are have very volatile freight rate, maybe the shipping lines are more likely to join in the shipping lines. Okay, so this is possible. There may be two-way relationship, right? Or you may argue that, okay, there are some unobservables that can jointly affect the shipping alliance and affect the freight rate volatility, right? Okay, so if this happens, your regression, you may argue, so this regression is wrong. It has the endogeneity problem, right? So I actually agree with this argument. So because the current study is still preliminary, so next step, actually, we are trying to solve this a possible endogeneity problem. So one common way is to use the instrumental variable, okay? So you may come up with an IV, which actually influence the shipping alliance decision, but not directly affect the freight rate volatility, right? So if this is the case, then this instrumental variable is valid. We call this exclusion condition. And also this instrumental variable should be relevant. It should affect the shipping lines, shipping liners alliance decision, right? So how do we come up with this IV? Actually, if you look at this table once more, okay, you will see that on the 2017, there is a very important structural change in the shipping alliance market. O3, G6, CKY, HE, so they restructure themselves to form two new shipping alliance. And also there are a lot of the mergers and acquisitions during this period. Okay, so all these actually market structure change are not specific to one route, or their timing is not determined, right? Even though two shipping lines, they decide to merge each other, the exact effective date is random, okay? And also they are implemented market-wide, not specific to one route. So we can actually believe this structural change can be a valid IV. So in the next step, we are trying to use this market structural change as the instrument variable to solve this possible endogeneity problem. Okay, so there are also some other detailed market structure issues, but because of the time limit, so I'm not able to go into details. Okay, I'm sorry, I'm a little bit delayed in time, and welcome your comments and further discussions. Thank you very much.
Okay, thank you, Dr. Wang. And I have to say, it's very interesting study and very comprehensive, including theoretic build-up, theoretical model, and also empiric, and also IV. It's very interesting. So I would like to ask if there is anyone, or let me see. Okay, I found one question here from Li Lu. And the fourth question is, the CCFI is all-in price, including freight rate and the seaborne surcharge, such bunker adjustment factor, fuel adjustment factor, which means it may already the fuel oil volatility. And my first question related to the collinearity problem with CCFI and fuel oil. Volatility. I think you can read this, right?
Oh, yes, Dr. Yang. Yeah.
Yeah. No problem. Now I will ask Dr. Wang to answer 2 questions. Then if you have further questions, we will leave this in the end of today's webinar. We will leave like 10 minutes for you to ask a question. So Dr. Wang, can you help to answer the 2 questions here?
Yeah. Thank you, Li Lu, for this excellent question. You are correctly right. The CCFI is actually a price including many surcharges. So here maybe it's not very accurate to claim the CCFI as the freight rate. But I can tell you is that in our theoretical study, actually this proposition 1 still holds for the total shipping cost. Okay, so if you add the surcharges and the port charges into this freight rate in this model, the conclusion is qualitatively the same. Okay, so this does not affect the validity of the modeling and the empirical results, but thank you for the reminding. And also you mentioned that the volatility of the crude oil price is also included in the freight rate. I'm not very sure because as I mentioned, yes, the cost volatility, the fuel price volatility will contribute to the freight rate volatility, but it's not on the 1% by 1% basis, right? It has to be through the market structure and also the profit maximization strategic responses of different players in the market. So that is the purpose of this study. Yeah.
Second question, she asked, the cooperation actually also exists among the alliance, not only within alliance, but also, some kind of cooperation exists among the alliance. So how you exclude this effect in your research?
Yeah, this is also a very excellent question. So this is the how do you define alliance? Actually, in our empirical study, we consider this problem because in our data set, we can distinguish whether this container slot is booked, is sold by independent shipping lines or by shipping alliance or by some corporations. So we can identify. So actually in the empirical study, we adopt a very broad definition of the shipping alliance. Maybe 2 shipping alliance, they do not shipping liners, they do not belong to the same shipping alliance like 2M, like THE or Ocean. But in the data set, we can see they jointly share the capacity. So we also regard them as a shipping alliance. Yeah, so that's the direct answer to this question.
Okay, thank you, Dr. Wang. Actually, Li Lu is my PhD student. We are conducting similar research as yours, so we have such kind of question. So thank you for your presentation. Very excellent.
Thank you.
Yeah. Okay, now our second speaker is Professor Zheng Siyuan from Shanghai Maritime University. And Professor Zheng has very long history teaching shipping and also have very good publication in recent years. I can see he published paper in Transportation Research Part B, Part E, and a lot of top transportation journal. Now I will very honored to invite Professor Zheng to give us a presentation here. So Professor Zheng, it's your time, please. Thank you.
Thank you very much, Professor Yang. And so first of all, let me share my slides with you. Now I have shared my slides. So can you see my slides?
Yes, I can see.
Okay, thank you. Thank you very much. And first of all, I'd like to express my sincere appreciations to Professor Lai and Professor Yang for your invitation and give us such a good opportunity to communicate with scholars all around the world. In today's webinar, I'd like to say something about the following topic, say joint investment on transport infrastructure resilience from the cross-country perspective. So I should say in the current stage, it's a very preliminary draft, and all your comments and suggestions or even criticisms are very welcome. And this work is done by me and Professor Wang from UIB, a speaker a moment ago, and Professor Fu from the Polytechnic University. And we know it is common that multiple countries jointly invest in cross-border transport infrastructure, such as the cross-border bridges, tunnels, railways, and highways. For example, in the year 2013, China launched the Belt and Road Initiative. As a major investor, China has cooperated with over 180 overseas countries in seaport, airport, railway projects, with investment value over $250 billion as of 2020. So in such a cross-border transport infrastructure, we have summarized there are the following features for such a project. Still, we use the one important project in the BRI, say the China-Euro Railway Express project. We know the China-Euro Railway Express project linked with the Central Asia and Europe to facilitate the bilateral trade between these regions. And first of all, we know as the main investing countries, for those Central Asia and Eastern European countries with stressed budget, China provides the majority of the fund, and sometimes even be the sole investors. So we have the first characteristic for such a project, that is, we have one, we say dominant, or we call it investing countries who can guide the whole project and maybe overtake the most part of the investment.
Professor Chen, here I can still see the title page.
Sorry.
Yeah.
Can you see the slides now? The other
I
slides?
can see the slide, but in the title page.
Okay, I see.
Yeah.
Let me check. What happens? Now, can you see the changing slides?
No, still in the title page.
Okay. Let me try again.
Okay, now to the introduction.
How about now?
Yes, I can see the introduction.
Okay. Now you can see the change of the slides, right?
Yeah, now I can see its introduction.
Okay. Thank you. Sorry for the inconvenience. Let me continue my presentation. We have said we use the China-Euro Railway Express project as an example to show some typical features for such a cross-border transport infrastructure. We can find that there is a main dominant countries to manage such a big project. So for example, China, as we call investing country who may take the most of the investment sometimes. Then we can find another feature, that is the CR Express is operated by Chinese railway operators. It serves the freight transport among the different en route BRI countries and their businesses. So we have another feature, that is the investing countries may provide the transport service along the cross-border, along the countries on the cross-border infrastructure project. So those are the two main features in such a cross-border project. And we know that unlike the domestic transport infrastructure, the cross-country facilities are subject to more diverse disruption risks, damaging their operation resilience. So these risks includes the geopolitical uncertainties and some local unstable political and social conditions and some cultural differences, which may lead to some terrorism attacks or the local strikes and the protests. And also some extreme events, for example, the extreme weathers and the COVID-19 pandemic in recent years also adds the more disruption risks on these cross-country facilities. So to maintain the cross-border transport infrastructure, closer coordination between the different countries are necessary.
Professor Chen is still in the introduction.
Oh, okay. Why? Let me see it. How about now?
It's in introduction.
Okay, now you can see the scrolling of the slides, right?
Yeah, I can see.
But why when I broadcast it stopped?
Now in the introduction, but it's page 3.
Yeah, I know. Now the question is, if I make the broadcast model, it will be stopped. If I use the framework under the slide and the PPT, it can be changed. Why?
Okay, next time when you change the slide, you may inform me, then I will check. If no problem, I will stay silent, but otherwise I will remind you.
Okay, thank you. Okay. Now I changed the new slides. Can you see it? Now the slides 4.
Yeah, no, it's still in 3.
Okay.
Oh, now it's in 4.
Okay. So we say in order to maintain a cross-border transport infrastructure, we need a closer coordination between the different countries. And sometimes these countries, they have different objectives and different incentives in the power or information. And another important issue in such a coordination is sometimes we say in such a cross-border transport infrastructure, there is a dominant country who manages the whole project, but the investment also needs the support from some local countries. However, in sometimes the local countries, their investment on the resilience of the project cannot be verified, cannot be verifiable. So we call it non-verifiability. So such a non-verifiability will lead some a severe problem in the coordination. And also the investing countries has to design the appropriate mechanism to introduce the host countries to make the sufficient investment to guarantee the resilience of the cross-country transport infrastructure. So here we have suppose we have 2 countries. One is the dominant country who can manage the whole project. We call it investing country. For example, such as the China in a BRI initiative projects. And the other is some local coordinated countries. For example, some countries in the Central Asia, we call them host countries. So in our study, we try to investigate the coordination between the hosting country, investing country and host country. So now I changed another slide. So can you see the new slides?
Yes, I can see.
Okay, thank you. So now it introduced our research questions. Mainly, we have 3 research questions. First of all, how to determine the scale and allocate the investment on the transport on this cross-country transport infrastructure resilience along the different countries who share this transport infrastructure, and at the same time they have different incentives and objectives. 2, how does the investing country regulate its transport service providers, and what are interactions between the cross-country investment and the transport regulations? As we have said, still we use the China-Europe Express project as example. In such a project, the China Railway Company, they provide the transport service along the China-Euro railway system. So we know now it's introduced a question that is the investing countries. They as one side they need to regulate its transport providers, and the other side they need to manage the coordination and the joint investment. So we will try to investigate what are interactions between these 2 issues. And the third question is, what are impacts of the competition from other transport mode on the cross-country investment and transport regulation? For example, we know if we want to transport cargo from China to the Central Asia and to the Europe, you can also use the maritime transport. So here, the maritime transport and the railway transport, they have the competition relationship. So we will investigate what are the impacts from the other transportation mode. On the literature review, we have reviewed the related literature from the following 3 streams. First is that's a construction and operation on cross-country transport infrastructure. Second, risk management on this cross-country transport infrastructure. 3, investment on the resilience of transport infrastructure. Compared to the existing studies, we find that there's some research gap. The first is few economic analysis. Of course, we choose literature related to the economic side. So few economic analysis to examine the resilience investment decisions to deal with the unconventional disruption risks which need joint investment from the different countries. And the second, few investigation on the non-verifiability of the local countries or host countries' investment on this cross-country transport infrastructure. That's the main point we try to solve in our studies. And the third one is few discussions on the interactions between the resilience investment and the transport regulation. Next, I will briefly present our model. First of all, in our study, we assume there are 2 countries in order to simplify the problem. One is the dominant country manages the whole project. We call it the investing country. And the other is some local partners. We call it the host country. Suppose these 2 countries, they jointly make investment on the resilience of the railway corridor. So in our study, one transport mode is railway. And this is the consumer's utility in country I from the cargo transport. So here we can find there's one feature for this utility function, that is another country's transport volume will have the negative impact on country I's consumer utility. That is easy to understand because these 2 countries, they share the same transportation service. If we allocate more traffic to country J, then it will crowd the transport capacity from country I. So that will harm the consumer's utility in country I. Then from the consumer's utility function, we can derive the transportation demand function. Then we introduce the symbol D to indicate some predicted loss from the disrupted risks. And because such a disaster may be a stochastic event, so we use the probability rule to indicate its probability of occurrence probability. In order to reduce the occurrence of the disaster, 2 countries, say the investing country and a host country, they make the joint investment to reduce the probability of the disaster. Of course, they need to make the investment, and their investment needs some cost. So in order to get some closed form solution here, we use the quadratic investment cost function, which is commonly used in the related literature. And also here, the investing countries will provide the railway transport service. So that means that the train companies in country I, in the investing country, will be regulated by the country I's government. So this is transport company's profit function. Here we normalize its operating cost to 0. And these 2 are each country's local welfare. So we can find for the investing country, its local welfare consists of the 3 parts. The first part, is consumer's net utility, which equals to the consumer's utility minus its transportation charge. Then the second one is the transportation company's profit, because this transportation company is included in the investing country. So its profit is included in the investing country's local welfare. Then the third one, that is the resilience investment cost and the effect of the resilience cost. We say the resilient investment cost is used to reduce the probability of the disaster occurrence. And the second one, that is another, let's say, host country's local welfare. Compared to the investing country here, in the host country, there's no the transportation company's profit. Then we will make the study on the 2 benchmarks. The first benchmark, we call it first best of the, sorry.
still in previous page.
Yeah. Sorry, I forgot. Now, can you see it?
Yeah.
Oh,
But
okay.
I suggest you may speed up a little bit because it's already.
Okay, I see. Okay. So the first is the first best benchmark for the centralization, which means now we consider the ideal situation. Then the two countries, they jointly maximize their total welfare. So here we have the conclusions to describe the optimal investment allocation and transport arrangement. Here we can find the outcome depend on the probability of the disaster occurrence. If the probability is lower, we call it the full coverage. And if the probability is high, we call it the partial coverage. We can find such a probability has a crucial impact on the outcome. Then another benchmark is also the first best for the decentralization. In a decentralization case, that is the investing country will make the whole plan. So that means its objective is to maximize its own local welfare, say the investing country's local welfare. Yeah, first best means the local country's investment can be verified. So here in this problem, we can see the investing country can directly control or directly regulate the resilience investment of the host country. Then we have the outcome for the first best of the decentralization. Then the interesting issue is we use these two figures to indicate the main characteristic for the outcome of decentralization. We can find that the left side figure indicates the investment allocation between these two countries. So we can find that in the FC, say if the probability of occurrence is lower, then the disaster can be totally covered. Then we can find that if the market scale is small, we can find the two countries, they evenly allocate the whole investment. But as the market scale increase, we can find that the investing country will move some of the investment to the host country, to the local country. And if the market scale is large enough, then the host country will undertake the whole investment. We will explain why this happens. And the right figure indicates the traffic allocation between these two countries. Still, we can find if the market scale is lower, we can see both countries have the same traffic allocation. But as the market scale increase, we can find the local country, say the host country, will be allocated more traffic. Why this happens? Okay, we say if the disaster probability is lower, so in our case, that is the partial coverage, PC, that if the market scale is small, then we can see the investing country has to subsidize the host country to guarantee its local welfare will be non-negative. So if investing country subsidize the host country, then the latter's welfare will be internalized. So that is why these two countries should have the equal allocation for their total investment. However, as the market scale become larger and larger, then we can see the host country can use the large market scale to cover its costs, investment costs. So it's make unnecessary for the investing country to subsidize the host country. Without subsidy, the host country's welfare cannot be internalized. So we can see at this time, then the investing country can move some of its investment to the host country. And so if the transporting market scale is large enough, the host country at the same time is allocated more traffic. He can use more traffic to cover its investment cost and to increase, and also increase the profit of the transportation firm. The transportation firm will take more business from the host country. When the disaster probability is high, we can see the centralization outcome can be achieved, and whether the investing country need to subsidize the host country will depend on the market scale. Now, what implications can we obtain from these two benchmark cases? First of all, we can see that the cost investment allocation will depend on the resilience task, or in our case, the disaster probability. When the disaster probability is lower, then we can see the investment allocation may not be even. And in sometimes the host country may undertake more investment. And meanwhile, that another important interesting implication that is it is possible that investing country will have more transport businesses from overseas, say from the host countries. He can, in one side, he can take some profit from the host countries, and on the other side, more traffic from the host country can be used to cover the host country's investment cost. And when the resilience task is high, in our case, that's the probability is high, then we can find the investment should be allocated between these two countries evenly. And also whether the host country should be subsidized depend on the transportation market scale. Then next, we go into the key questions. If the host country's investment is non-verifiable, how to deal with this problem? So compared to the previous investing countries problem, we can see here we add another constraint in this optimization problem. Now the host country's investment cannot be directly controlled by the investing countries. Rather than this investment should be decided by the host countries because it's non-verifiable. So the investing country cannot directly control it, but it should control it by the indirect tool, say the host country's traffic. So here we need to add another constraint we call incentive compatibility constraint, which guarantees that the host country's investment is used to maximize the host country's total welfare. So solve this problem, we can find that, first of all, if the disaster probability is lower, that is FC problem, FC scenario, we can find the outcome the first best outcome can be achieved. So in other words, the non-verifiability has no impact on the result. However, if the disaster probability is high, we can find that all the investment, including the investing country and the host country, their investment will be downwarded, will be lower than the first best. So next, we make the compare between the second best and the first best to indicate the impact of the non-verifiability. We can find that their impact are different between the full coverage and the partial coverage. Here we can find that in the partial coverage, the non-verifiability is may cause some severe problems, say the downward the resilience investment, and at the same time upward, say high transportation cost. And also, but another interesting issue is the subsidy. If we compare the subsidy between the second best and the first best, we can find the comparison results are uncertain because unlike the classical moral hazard problem, now the principle, or in our case, that investing country, they can use different ways to incentive the local countries. On one side, they can use subsidy. On the other side, they can allocate more traffic, then which can be used to cover the host country's deficit. Now we have some implications from the comparison. We can find that the non-verifiability sometimes has the problem which will lead to the distortions if the resilient task or the probability is high. And also the subsidizing the host countries may not be necessary because the investing country can use different ways to realize their objective. In the final part of our study, we have made some extensions. We consider competition from the other transportation mode. Say, for example, in our case, we consider the competition from maritime transport. So in order to do such a work, first we have to revise the utility function and also the demand function. Then we need to say here, now we have to introduce another companies. Now we have two companies. One is a train company to provide the railway service, and the other is shipping company to provide the maritime services. Here we need to emphasize that only the train company's profit are included in the investing country's local welfare, because the shipping companies sometimes they are internationals. So their profit are not included in the local welfare of the two countries. After repeating our previous work, we can find that the main conclusions are similar compared to the case without competition. And next, we focus on the issue whether the competition between the different transporting modes will have some impacts on our result. We can find that the increasing competition will reduce the maritime output. And at the same time, if the transportation competition is high, then the increasing transportation competition will promote the railway output. At the same time, will may cost a high investment, resilience investment. So through our study, we get some conclusions. Mainly, we discuss the non-verifiability of the host country's resilience investment on the impact of the investment on the traffic allocation and on the local welfare. And in terms of modeling, we try to set up an integrated model to investigate the investment allocation on the resilience of cross-country transport infrastructure and the regulation on the transport services providers. Specifically, we examine the allocation scheme, especially when the host country's investment is non-verifiable. And also we get some policy implications. We review that in some cases, the non-verifiability will lead to the distortion of the outcome, say the downward distortion of the resilience investment and upward distortion on the transportation price. And also we find that the competition between different transportation modes will affect the output and the resilience investment. So that is my main presentation. I should say now it's still in the very preliminary stage. So any comments and questions are warmly welcome. Thank you.
Okay, thank you, Professor John. I just have a simple question here. I just wondering if possible to conduct an empirical study on the theoretical analysis, because I think it's urgent and very interesting topic. But I think since it's huge, you know, it's cross-border infrastructure. So I just wondering if it's possible to have an empirical study on this.
Thank you very much, Professor Yang. Yeah, it's a good question, and it may be one of the task for our future studies. But we find some difficulties for collecting the data, especially in our case. Maybe the probability estimation for some disaster may be difficult, because such a different disaster may be difficult to estimate. That's the first one. And the second one, that's investment. We know for some countries, this investment may be relatively easy to have, but for some other countries, for example, if we want to try to find the data for the investment on Central Asia country, it may be difficult. So we find maybe the data quality and whether we can get data is the main problem for the future empirical study. Thank you.
Okay, thank you. Since time limitation, so I will invite our final presenter. Then I will leave like 10 minutes for Q&A. Okay.
Okay.
So,
thank you.
Finally, I would like to introduce Dr. Dai from Shanghai Jiao Tong University. Dr. Dai is very young and talented research, and I noticed him because he also published a lot of good publication in recent year. And Shanghai Jiao Tong Daxue is one of the top university and with the shipping major in the department. So now I will leave the time for Dr. Dai. Dr. Dai, thank you for accepting our invitation. So now it's your time, please. Thank you.
Okay, thank you. Can you see my screen?
Yes, I can see very clear.
Okay, thank you. Thanks the invitation from Hong Kong PolyU. It's my great honor to show my current research to all of you. And the title of my introduction is Optimization of Shoreside Electricity Subsidies, Considering Port Competition and Cooperation, a game theoretical approach. And this is a work in progress. So we sincerely welcome comments and suggestions from the colleagues. And my presentation consists of 5 parts. And firstly, let's see the introduction. We know that shipping is critical for the global economy, as it undertakes nearly 80% of the trade. But on the other side, we should also be aware that shipping accounts for a certain amount of greenhouse gas and atmospheric pollutants. For example, the CO2 emission of shipping worldwide accounts for nearly 3% of global emission, and for SO2 accounts for 4% to 9%. And other pollutants like NOx and BC also accounts for a significant share. And also, according to IMO, if no measures are taken, the world shipping CO2 emissions in 2050 would be doubled than that of the level of 2008. So it's urgent to reduce the global shipping emissions. And for the overall shipping emissions, I think the import shipping emissions is significant and harmful. We don't have the exact data for the global level. We took the port of Shanghai, for example, based on some research that ships at the port of Shanghai contributed 12.4% of SOx, 11% of NOx, and 5.6% of particle matters in Shanghai's total air pollutant. And since we know that Shanghai is a megacity with more than 20 million citizens, so those kinds of pollutants is very harmful to the health of the citizens. And also shipping emits a lot of greenhouse gases, especially for CO2. And among a lot of measures to reduce emissions from the shipping, the shoreside electricity has been one of the most promising technology or field for reducing import shipping emissions. Shoreside electricity also could be called as onshore power or cold irony, because it allows ships to turn off their auxiliary engines and plug into an electrical grid while at berth. And theoretically, this has zero emissions, both for GHG and pollutants. And here's a simple systems schematic map for shoreside electricity. We can dim it as we drive an electric car and charge to the shore side. And across the globe, many countries have issued a lot of policies to promote the usage of SSE, and many are financial incentives. And we took the China, for example. Currently, more than 50% of berths of major ports are capable of supplying SSE to ships. For example, for the port of Shanghai, they provide financial subsidy for not only the ships, but also they provide the subsidy for the ports. And we took the Shenzhen city, for example, they provide full subsidy on electricity price cap to the ports. But actually, based on our investigation, we found that there are some barriers that hinders the usage and promotion of shoreside electricity, not only in China, but also to other countries. We categorize the barriers into 3 parts. The first is the low intention to use. That's partly because the price of the electricity charged in port may be higher than burning diesel. And also, the second is the low service quality, because sometimes in ports, when ships they tend to use the shoreside electricity, it takes a relatively long time for the processing, for plug in and plug out, and sometimes they may wait for the facility. So the quality, surface quality may be poor that hinders them to use. And also there might be a complex subsidy structure between the government, the port, and the ships. And the ports and the ships are reluctant to use the shoreside electricity. So, and here is a structure of the subsidy. And we, based on this structure, I can introduce the dilemma of the SSE faces. That we know that government is the key stakeholder that wants to promote SSE because they want to zero emission import. And so they are willing to subsidize the ports and the ships, but their objective is to maximize the effectiveness of the subsidy. But for the ports, like they need to sell the electricity to the ships. But sometimes, if the price of the electricity is higher than the equivalent cost of the diesel, the ships might not use SSE. But if the port sell at a relatively low level of price, then the port will suffer an economic loss. And for the ships, they face the similar problems. So here is a dilemma that the government has invested heavily because they invested a lot on the facility construction and installation. And even like some ports are equipped with the infrastructure of electricity, but many ships do not use it. So a lot of investment is sunk. And here we may find the new dilemma, like if we have multiple ports within one government, the dilemma would be more complex because then the ships would have other choices to port 1 or to port 2 to get charged or not get charged. So based on this situation, and we come to figure out some problems. And the first, we would like to figure out that when under the one government administration, if there are two ports, whether the ports will choose to compete with each other or cooperate with each other then under these circumstances, the port competitiveness would have multiple dimensions apart from the traditional, like their cargo handling service price and cargo handling service quality. Like the shoreside electricity service price and quality might also be an important factor that accounts for the competitiveness. And the research question of our current research falls in the area that considering like the port, the government port ship structure, if we consider the potential competition or cooperation among two ports, will the government achieve its original objective of like achieving the maximization of its environmental benefit? And when, if government could achieve its objective by optimization the set of the subsidy, how could port 1 and port 2 achieve their objectives of maximizing their revenues? So based on these research questions, we formulated our research. And second part is the literature review. And a lot of researchers has invested related issues, and they proved that SSE is effective in reducing port emissions, but the economic performance is not that good. And a lot of like countries or international institutions have issued relatively regulations or policies to introduce the usage. But based on the past research, we can see that even though some policies have been issued, but the utilization of shore-side electricity cannot be guaranteed. So currently, the optimization of the subsidy structure among the government, the port, and the ships has been a relatively hot research issue. And we think that the optimization of the subsidy scheme, considering the interactions among the different parties, is a lack of discussion. So based on the literature review and the practical problem we investigated, so we think that to improve this service quality, to improve this problem from the perspective of improving service quality of SSE might be a practical and feasible solution. So we design our research. Also, we use these from the game theory perspective. And then we'll briefly introduce the notations and assumptions. And here are some basic parameters and decision variables. And three key decision variables. First, S stands for the unit subsidy for SSE. This is given from the government side. And then the EI stands for service quality of SSE import I. And we have PI. This stands for the electricity charging service price of import I. And also we have some basic assumptions. The first assumption that the carriers vessels in this study are assumed to have equipped with facilities. And the second assumption that the two ports are geographically close to each other and the carrier is free to choose the port. And third assumption that the carrier is free to choose whether to use shoreside electricity or diesel to replenish the vessel's energy while berthing. And fourth assumption that the port electricity demand is linearly related to port size, service price, quality, diesel price, and competitors' price of service. Obviously, some factors are negatively affected. And then briefly introduce our game model. We designed 4 scenarios of this problem. We could see that based on the investigation, the government could subsidize firstly to the port, and then from the port, reduce the sale price to the ships. And also the government could directly subsidize to the ships. So they have 2 categories. And within each category, we have 2 scenarios that the port competes with each other, or the port cooperates with each other. So with these categories, we have 4 scenarios. And we formulate a Stackelberg game that firstly, the ports choose to determine their own optimal electricity price and service quality. And then the governments, based on their decision, the government decides the optimal subsidy mode and amount to achieve its objective of achieving the maximum of environmental benefits. That is the largest CO2 emission reduction. And when port 1 competes with port 2, they tend to maximize their revenue respectively. If for cooperation, they tend to maximize the sum of their revenue. And for the government, they tend to maximize the environmental benefit. That is the monetary representation of the CO2 emission reduction. Here are some formulations of which we're not gonna explain detail, but as we explained before, that the Q stands for the quantity of the demand of electricity import that is linearly correlated with some factors. And the pi stands for the revenue. We can see that it is that the revenue minus the cost of improving the service quality. So if wants to obtain better service quality, it has to pay higher cost. And then let's skip to the results and discussions. And first, the proposition one is that we found, based on the mathematical formulation, we found that theoretically, the government subsidized to the port, or the government subsidized directly to the ships, they have the same effects. So we compress the 4 scenarios to 2 scenarios. Then we just need to see port 1 compete with port 2, or port 1 cooperate with port 2. And then we have the lemma 1 that the optimal electricity service quality of port I is increasing in the unit subsidy, unit price of diesel and its own potential demand, but it is decreasing in the price of electricity. And also this the proof is consistent with some facts. For example, if the government subsidies increase, the ports would like to improve the quality of the electricity services to attract more ships to use. And if the diesel prices increase and more ships would prefer to use SRC, and port will also improve the quality of the SRC service. And we have the second lemma that the optimal electricity service price is increasing in unit price of diesel, its own potential demand. It is decreasing in price of electricity. This could reflect that when oil prices rise, so does the price of the optimal electricity price. And when ports increase the price of handling services, they may reduce the price of electricity to ensure the throughput. And the second proposition is that if the potential demand of the 2 ports are the same, the optimal shoreside electricity service price and service quality will follow the following order. The price of scenario 1 is smaller than the price of scenario 2. That could be explained that if the ports choose to cooperate with each other, the optimal electricity service surcharge and service quality will be higher than choosing to compete. So from this perspective, cooperation might be better in improving the service quality. And for the third lemma, that the actual demand of electricity of port I is increasing in the unit subsidy, unit price of MDO, its own potential demand. And we could see that if the government increases the electricity subsidized, the use of electricity imports will increase. When oil price rise, ships will tend to use electricity and the usage will increase. And then we have the third proposition that if the potential demand of the 2 ports are the same, the usage would follow the following order. The quantity in scenario 1 is larger than the quantity in scenario 2. So this reflects that the competition between ports will be more likely to boost the electricity usage and induce larger emission reduction. And then for a lemma form proposition 4, that in both scenarios, the optimal unit subsidy for electricity is increasing in the unit environmental benefit. And this could be explained that the optimal government subsidy unit price is only relevant for the environmental benefits of CO2 emission reduction. The higher the environmental benefit of CO2 emission reduction, the higher the government should increase the subsidy for SSE. And then we could see that some results that in general, the incremental use of electricity and the incremental benefits to government are also proportional to the level of subsidy per unit. The government should encourage competition between ports to increase the usage of the electricity. And finally are the conclusions that based on the previous research, we find that the government can choose to subsidize either to the port or directly to the ship. They have the same effect. And the unit price of the government subsidy should be related to the environmental value of the CO2 emission reduction. If the value increases, the subsidy should increase accordingly. And the government should guide the ports to try to increase the usage of electricity through competition. The electricity service surcharge can be increased when diesel price rises, but when the SRC service surcharge should be reduced when the price of electricity rises. This will ensure the competitiveness of the port as well as the usage of the electricity. And that's all of my introduction. Since it's a work in progress research, we welcome comments and suggestions from the colleagues. Thank you.
Okay, thank you, Dr. Tai. I think it's very significant. This research has great significance because I know I have worked in Ministry of Transportation. They put a lot of effort encouraging port to use onshore power system. So I received one question in the chat room from my colleague, Charlie Ahim. He said, with optimal in your research, do you mean equilibrium of the gain? So can you see the question here? With optimal, do you mean equilibrium in your game? Because your title has word.
Yes, I see this in the chat. Yes.
Okay.
When they achieve the Nash equilibrium.
Okay, thank you. Okay, now all three presenters finish the introduction of their research. I learned a lot from the research, and all of them I think is very interesting and well done. So now we still have few minutes. Actually, it's already 5:30, but we may leave some time for our audience to ask a question. If you have any question, you can either speak up or leave your message in the chat room. Any question here?
Well,
yeah.
If you don't mind, so I have one question for and I always have difficulties pronouncing the names correctly, but I still do it. Yan.
Yeah.
Okay, so one question. One is because you distinguish between verifiability and non-verifiability,
right.
And I was wondering, based on your understanding of the markets, which scenarios would you consider more relevant? That would be one question. The other one is for the last speaker. I would suggest, because to me, the framework looks relatively, I would say, you discuss it in the context of ports, but I think the framework may also be relevant for many other constellations, not necessarily involving ports. And one example for this is, because I'm interested in air transport, also maritime and so on. But, your first result, for instance, saying, if you pay the subsidy to the company or to the port or to the shipping lines, it doesn't matter. That is something that is very, I would say, for me, not a big surprise. For instance, when we talk about congestion, and then we have congestion costs to, for instance, paid by the airlines or by the passengers, and it doesn't really matter. Only thing that matter for the congestion fee would be the overall cost, so to say. It doesn't matter who bears the cost, so to say. So that would be these two, one comment and one question, so to say.
Okay. So, Professor Chen.
Okay, thank you very much, Professor Cheney. Your question and the comments are always very helpful, although sometimes it's difficult to answer. For your first question, in this study, we try to discuss some resilience investment. Here, resilience or disruption risk, including, for example, for some safety and security, or some investments the local government, maybe they used to prevent the terrorist attacks. So for some investment, if this investment is used on the safety or on the improving the infrastructure condition, we think this can be verified, maybe easy. But if this investment is used on some prevention of terrorist attacks, for example, the government, the local government, they will use this investment to enhance their military strength. Maybe this is difficult for the other countries to verify, to find. So that's my answer. I don't know whether this is correct or not. Thank you.
Yeah,
Okay.
thank you.
Thank you, Professor Chen. So Professor Dai, actually from him is a comment, not a question. But do you like to say something, or it's okay?
Oh, thanks a lot for Ingo's comments. I totally agree. And based on the, for example, based on like our instinct or the industry practice, I think you have the conclusion that they have the equal effect, and we have based on our mathematical modeling and based on the calculation, we also get the conclusion that they have the same effect. I think that's very good. And that means we do not go to a wrong conclusion. Thanks for your comments.
Okay,
Thank you.
So Mike, I think we almost at the time. It's 5:40. So
Yes. Now it comes to the end of this webinar. I would like to thank the three speakers for their sharing of the port management issues, particularly about the models and also the insights on about the port resilience and also their sustainability. So thank you very much for this free speaker. And this webinar has been recorded. And as you see in the chat room, the recording will be posted in the YouTube channel of the PolyU. So you can review about the contents of this webinar. And we will organize another webinar in late November on the topic of smart port. So which will be an activities to celebrate the Maritime Week 2022. And I will send you the webinar information about the time for your registrations. And thank you again for joining this webinar. I hope that to see you again in November on the topic of smart port. Thank you very much. Bye-bye.
Thank you very much, Professor Lai. Thank you very much.
Bye-bye.
Thank you very much. Thank you for your support, and bye-bye. Thank you all the audience. Bye-bye.
Thank you, Professor Yang.